Suppose I were to ask you, what is the measure of this angle right here, notated by this little box? Well, I have to believe that every single one of you out there would instantly be able to shout, say, I know, Mr. Klein, that is a 90-degree angle. And you'd be correct. That is absolutely 100% correct. And I know you all know that. However, one thing I'm not sure if you realize, there's actually another unit of measurement you could use to give the measure of this angle, and that is called a radian. You would also be correct if you said, Mr. Klein, that angle is a pi over 2 radians angle. And that would also be correct. See, these are equal to each other. You've spent your entire lives measuring angles in degrees, which there's nothing wrong with that. But realize there's also another way to measure angles called radians, and that's what we're going to focus on today. You know what this is like? It's real similar to, like, if I asked you to measure, if I gave you a line segment, I said, hey, measure this line segment, and you get out your ruler. We kind of spend our whole lives learning how to measure things in like inches and feet, but then suppose at some point, I'm sure you realize that you could also measure something like this in centimeters and say, oh, that's about 5.52 centimeters. Now, both of these are correct. It's just a different unit of measurement. That's the same way that it is between degrees and radians. So let's go to today's goal. Today's goal, I'm going to teach you how to convert from a degree to a radian. So let's start with this. What exactly is a radian? Well, a radian is here, this angle right here, and I'm going to highlight this in pink. This angle here, kind of highlighted in pink, is called a radian. You can look at it and say, oh, it looks like it's about 60 degrees, but that's called 1 radian. A radian is the measure of an inscribed angle inside of a circle, where that causes this arc, the arc of this circle that I'm going to measure in yellow, I'm going to highlight here in yellow. This is the specific angle measure that causes the measure of this arc in yellow to equal the radius of this circle, which is one of these pink lines. And so, a couple things I want to write here. 1 radian is approximately equal to 57.3 degrees. Okay, so it's close to 60 degrees, a little bit less than that. It's 57.3 degrees. And then here's another thing I want to note. At approximately 57.3 degrees, which is 1 radian, the yellow arc of this circle equals the radius, the pink, one of these single pink lines, the radius of the circle. This yellow line is the exact same length as one of these pink lines, and that only happens at exactly 1 radian, or approximately 57.3 degrees. Okay, so that's the introduction. Let's get to the real kind of meat and potatoes of this lesson. There are simple formulas to be able to convert from degrees to radians and radians to degrees. So if I have something in degrees and I want to be able to write it as radians, the formula is this. I take the degrees and I multiply it by pi over 180. So definitely write this formula down. This is going to be a very important conversion formula for you. And on the flip side, if something's in radians and I want to be able to write it as degrees, I would say degrees is equal to the radians times the reciprocal of that, 180 over pi. And I'll show you one other thing you may want to take note of. A full circle, 360 degrees, is exactly equal to 2 pi radians. And you can abbreviate radians, RAD. Okay? In other words, so 2 pi is that's approximately, so pi is 3.14. 2 pi would be about 6.28. You could fit 6.28 of these yellow lines inside this full circle. It's a little bit more than 6. Sometimes I'll ask students, hey, how many of these yellow arcs do you think you could fit in this circle? And it's a little bit over 6. It's 6.28, about 6.28, which is 2 pi. And then you can cut that in half too. That means 180 degrees is equal to pi radians. Okay. Let's get into some examples then. So I have my formulas here. Over here, let's convert. Here, these are written in degrees. Let's convert them into radians. So 45 degrees. If I want to go from degrees to radians, I'm going to use this first formula. I'm going to say radians is equal to the degrees times pi over 180. Okay. Now, so there's 2 ways to write the answer here. Now, one way we could write this is we could do 45 times, I even have this little fraction calculator here. I'm going to show you something. So let me find my pi button. Oops, my pi button's right here. So 45 times pi over 180. Now you're going to see the answer comes out really messy. As a decimal, we could say that this is approximately 0.785 radians. And that's how we would write the answer as a decimal. However, that's not what I'm going to ask you to do today. I'm not really too worried about because this is an irrational number. So I'm not going to try to write this as a decimal right now. We want to try to avoid these messy irrational numbers. So what we're going to do instead is we're going to write this as a fraction. 45 over 180 times pi. And then we're just simply going to reduce this fraction. So on this handheld calculator that I have, this is actually a fraction calculator. I'm not going to do a whole review on how to reduce fractions. If you don't remember, if you do remember, great. If you don't remember, just find either a fraction calculator, or at the end of this video, I'll show you how to do it online. But this fraction actually reduces to 1/4. So this can be written as 1/4 times pi. Or a lot of times what we'll do is we'll take the 1 times the pi, which is just pi. We'll write our answer as pi over 4. Okay, let's practice again. So here, to go from degrees to radians, I'm going to look at my formula. I'm going to take degrees times pi over 180. Now what you're going to find is, rather than try to write this as a really messy decimal, we're going to actually just write it as a fraction and then simplify that fraction. Now here's how. Now on a handheld calculator, let me actually see how this comes out. Negative 225 over 180. Oh, so it actually tried to give this to me as a mixed number, which I do not want. On a calculator like this, if I want to go from a mixed number to what's called an improper fraction, I can hit second ABC. This is actually how I want to leave it as an improper fraction, negative 5/4. So since this reduces to negative 5 over 4, I'm going to write my final answer as negative 5 pi over 4. In essence, the pi in these cases will always just go back on top of the numerator. Okay, let's do one more. So here the radians would be 450 times pi over 180. So what I'm going to do is reduce this fraction, 450 over 180. Here is how I do it on a handheld Texas Instruments calculator, or any calculator with the ABC button. Of course, I'm going to convert that from a mixed number into an improper fraction, 5 over 2. So I, of course, would write this as 5 over 2, and I'm going to put the pi next to the 5 up on the top, 5 pi over 2. So this is how I go from degrees to radians. Here's some good examples. Okay, let's go then, let's try to do the opposite now. And radians is usually written with a pi. When you write an angle in radians, usually it has the pi in it, although occasionally it doesn't necessarily have to. But let's go over here, let's do the reverse. Pi over 3 radians, how am I going to write that in degrees? Well, the formula for this one, degrees is equal to the number of radians times 180 over pi. Now what happens in most of these cases, if your radians is written with a pi in the numerator, Well, then the beautiful thing that happens, these pi's cancel out. And you're simply left with 180 divided by 3. Okay, well that's simple. That's 60 degrees. So pi over 3 radians, 60 degrees. And you know what? That makes sense because that's just 180 divided by 3 is 60. So that makes perfect sense. All right, let's try this again. Degrees. Negative 3 pi over 4. I take radians times 180 over pi. Well, good for us. The pi's are going to cancel out. So all I really have to do here is take the negative 3 times the 180. You can hit equal if you want to. It doesn't matter. But then divide by this 4. Negative 135. And if you want to see that kind of all written out here, you could do that in one step if you wanted. It'd be negative 3 times 180 divided by 4. Comes out to negative 135 degrees. All right, now the last one here, this is an example where if your radians does not have a pi in it, it's going to come out really messy. Let's see what we can do this with. So I need to do radians times 180 over pi. So if it was 3 radians times 180 over pi, this is a case where technically, so 3 times 180 is 540. So technically, if I really wanted to leave it as a fraction, I could just leave it like this. But this is a case where typically we would just go ahead and round this answer, even though it comes out irrational. 540 divided by pi. Here's a good time to just round. We'll say 171.89 approximately degrees. Okay, and I'm going to put it in approximately equal to because that's not perfect. But in a lot of these cases, the question would just have you round it to either a certain decimal place or to the nearest whole. You would say this is 172 degrees. Okay, so here's all these examples. Here's all the examples done on a handheld calculator, a fraction calculator. Let's switch gears here. Let's switch to, if you don't have a handheld calculator, let's look at how we can do some of these on Google. All right, so flipping over to the computer here. First of all, I'm going to show you this little GIF here. So here you have a circle with the radius is r. You can see here in red here the length of the radius. Well, watch, if we bend that radius into this arc length, so this arc length would have the same length as the radius. That gives us an angle of 1 radian. Now watch here, as you can double that, triple that. You can see how half the circle would be a little bit more than 3 times as many as 1 radian. It's actually about 3.14 times as many, or pi radians long. And then if you double that, you get the whole circle. That is 2 pi radians. So this little graphic kind of helps you understand what a radian is. And I'll just kind of, for the record, radians is really useful. There's certain types of, when you really start studying circles and certain elements of trigonometry, believe it or not, you may not believe me, but there are times when radian measure actually makes the problem way easier than trying to do it in degrees. Okay, now let's get to the main point of today, of this computer part here. Let's look at your assignment. Question 2. How many degrees is pi over 6 radians? All right, well, let's write this out first, and I'm going to show you how you can use one of your calculators on the laptop or your Chromebook to find the answer. So to find this in degrees, we're going to do pi over 6 radians times 180 over pi. Now, you could very easily here, we know, I'll just do this one by hand. We could cancel the pi's out, and we're left with 180 divided by 6, and that is just 30. Okay, so this is one you could very easily do by hand. Let me show you, Desmos actually has a scientific calculator that I think is really interesting. So if you go to desmos.com/scientific, Desmos will give you a scientific calculator that does fractions. I want to actually see if it can handle this. Pi over 6 times 180 over pi. So it has a pi, this calculator here has a pi button. Pi over 6, and then let me move my cursor out to the side, times 180 over pi. And if I hit equals, Yeah, Desmos can absolutely handle this as well. So if you just really don't like doing this by hand, here Desmos calculator has a really handy way of making that happen, and you get this answer of 30 degrees. Okay, so let's try one in the opposite direction. Let's move to I believe this is question 8. Okay, let's try question 8 here. Here we're going the opposite direction. Convert 115 degrees to radians. Leave your answer in terms of pi. Well, let's kind of write out the steps here. To get radians, I'm going to go degrees times pi over 180. Or I can write this as a fraction with my pi kind of hanging out here over at the top. So I need to reduce this fraction 115 over 180. And if you don't remember how to do that by hand, again, I don't really want to take a lot of time to review this. Here, let me clear this out. Here, let me go down to the next line. If I do, in this Desmos calculator, if I do 115 over 180, and then click on this little fraction button, whoop, it'll automatically reduce the fraction for me. 115 over 180 becomes 23 over 36. So I know to write my answer as 23 over 36, and then this little pi symbol here would go on the top. This is how I would write the answer as radians. So it'd be that answer right there. And you know what? While we're here, I'm curious. One thing I don't believe Desmos will do, I don't think Desmos will let me type. Let me see what happens if I try to type all of this into Desmos. I don't believe this will work. Let me go down the screen here. If I tried to do 115 times pi over 180, I believe Desmos will just give me the answer as a decimal. It's approximately 2.007. Desmos is unable to convert this into a simplified fraction. So in a problem like this, we'd have to ask Desmos to simplify the 115 over 180 and then do the rest of the work ourselves. Okay, so I hope that makes sense. Best of luck on this assignment. Let me know if you have any questions. Bye.